Hello, welcome to today's webinar from Amplify. I will give a couple of minutes for everyone to join, so we will start 1 or 2 minutes after 4 p.m. Okay, I still see that people are joining. Let's give another minute. Okay, and with that, I would like to start the webinar. Thanks everyone for joining. Summer is getting close, and we're happy to have you here and learn something new, hopefully. My name is Christian Henke. I'm head of product at Amplify and have been running a couple of webinars already. This time I'm really happy to have our speakers from Meetr, a Berlin-based company in the housing industry, and they're going to talk about how Meetr has solved interconnectivity issues when developing their solution. And this is actually the first webinar of our series that we're starting now. So we are focusing now our IoT webinars more on IoT customer cases and partners. So traditionally, we have been talking a lot about cellular connectivity and the things that we provide, like connectivity anywhere and the seamless integrations into the cloud. But we want to give the webinars a little bit more content, which helps you to develop the solutions. And today it's the first webinar which presents an IoT customer case. So we will try to get in some of our customers from different verticals and use cases and let them have a talk about what have been their journey, what were the challenges and the solutions that they developed. Because we think a lot of the challenges are common across the verticals and industries, and this can help you to better design your solution. And we will also have partners that are presenting a different topic. For example, in 1 or 2 weeks, we will have a webinar about the IoT batteries, the best IoT batteries to use for cellular connectivity. So you have clear understanding and input for how you can design your IoT solution. So, and with that, actually, that's all. I just wanted to introduce the Amplify IoT webinar series, so what we're planning to do. I hope you find this useful. You can also give us feedback about the webinar series or what you want to hear from us in the coming webinars. Happy to take your suggestions. We will have a Q&A session after Meetr's presentation, so then the floor is also open for your questions, and I will also be able to respond to your questions. Okay, so with that, I'm going to hand over to Yannick Yannick will be introducing Meetr.
So yeah, hello everybody. Hope you can see my screen now. It looks like that. Yeah, I will start a little bit about Meetr. Then we go ahead with the connectivity challenges. We had discussed about some protocol solutions and also on bandwidth optimization. And as Christian mentioned, we go ahead with a Q&A session. Thanks again to the guys from Amplify. Thanks, Christian, for the intro. And also really nice that so many people signed up this afternoon. We go ahead with Meetr. Meetr is an IoT building management platform for the housing industry. Yeah, we are a Berlin-based startup founded by our CEO, Dr. Franke Bierke, 3.5 years ago with around 20 employees right now. I usually call it the done it before team. We have years of experience in founding startups, in Internet of Things, software as a service, analytics, and we also had successful company exits in the past. We put a lot of intense engineering, and a lot of product development into the solution. We did this together with 2 leading housing industry partners, which also became investors and our first big customers. And why did we do this? We saw a lot of challenges in the housing industry. So 60% of all buildings are older than 30 years. They have old existing legacy systems. Usually they are all island solutions from a lot of different vendors, and they do not communicate with each other. So this makes buildings really not transparent, really not efficient, and also not sustainable. And if we think of that, buildings also cause 36% of CO2 emissions worldwide, that's a big case. So we came up with a vision. We said we want to create a manufacturer-independent platform which supports cross-application workflows and enables a more efficient management of buildings. And with grabbing the data and visualizing it, we want to create the digital twin of a building. And how do we do this? We developed our hardware and software. So 2 years ago, we designed our own IoT retrofit gateway, just because there was nothing in the market that actually fulfilled our requirements. And yeah, we wanted something which is easy to install, because installations are really expensive. We needed something which is industrial grade and at least has a 10 years lifetime. It should be future ready and modular to also enable future business cases we don't know yet. And it should support the usual protocols in buildings. And this we will discuss obviously during this webinar together with Max. In general, we start with grabbing the data from existing hardware like heat or water meters or temperature sensors or current sensors we retrofit in the field. And because we do not have those data points available usually. And then we feed this raw data via like the raw data from the different devices and different manufacturers via our gateway and via LTE into our platform. So that's why a reliable connectivity is really essential for our solution, and that's why we also work together with Amplify. And then we have our software, which is the customer portal. It's actually all data in one place. It's about integration into billing software or ticketing systems, ERP systems in general. we offer real-time monitoring and automated reports and alerts. For example, a technician is sent to a building because the pump is not working correctly, and ideally this happens before a tenant complains or damages occur. We are live in more than 350 buildings already. We did around 12 million measurements already in the meantime, and hopefully this year another 1,000 buildings also go live. So how do we actually earn money as a startup? Obviously, firsthand, we are selling our own gateways just as a data enabler. And secondly, we charge software as a service fee per building on a monthly basis, for example, for our own products in different features and packages, and in combination sometimes with third-party solutions, for example, with elevator monitoring system. Our first product we launched this year was smart sub-metering. Most interesting case here is the monthly energy consumption information is by a legal obligation need to be fulfilled by 2022. And what our customers, for example, really like the most is that we are manufacturer independent. So the housing industry is more flexible in negotiating prices for the meters. They don't have this permanent lock-in effects over years, sometimes decades. And there we are tracking usually or reading the data out of the heat, water, and smoke detectors. Our second product is the guard for heating system. It's a retrofit solution, as mentioned, for the old legacy buildings and systems. With that, we can optimize the heating system. We want to increase the utilization and the uptime, and this usually leads to the reduction of damage costs. Our third product, the guard for water system, available from Q3 this year, is also a retrofit solution for existing systems. We are monitoring conditions for bacteria growth of Legionella. This also helps in reducing the costs through damage, or helps early detection to really find out if something goes wrong with the temperature limits in the buildings. And if we continue to our platform, as mentioned, we want to give our usually B2B customers access to a large amount and variety of building data. They do not have it right now, and therefore, with the data, we enable them to new business cases. So, or even generate higher savings through the combination of solutions on our platform. So this could be, for example, the integration of an elevator monitoring system of a Kone or a lift guardian to fulfill legal requirements, which are done right now manually by technicians every month, written on paper, or, for example, adding digital access systems like a Kiwi to give automated access to buildings when it's really needed to the right person. Right now, for example, you all know keys need to be physically handed over. People need to give access on site, and this is usually really a waste of time and resources. So in general, with our platform approach, we achieve lower investments on hardware and installation costs through our multifunctional hardware, and we use synergy effects on the software. For example, you only have a one-time integration of an API and not into several different systems. It's also a single point of support for the solution, and also has lower follow-up costs, for example, for maintenance, because you don't have several systems running in parallel. It's all in one platform in one place. And with that, I would give over now to Max, who continues with the connectivity challenges we faced so far.
Thank you, Yannick. So give us 1 second to change the screen. So, and now you should see my screen. All right. So, okay, so I wanted to talk to you about today about the connectivity challenges we had at Meetr and also how we overcame them. And this could be like an input to you if you're planning your own IoT solution on how to tackle issues on connectivity, especially if it comes to buildings. So for the first thing is like what we do. So we have a gateway that Yannick already explained, and this gateway is being installed in basements of buildings. As you can see here, we have these multi-tenant buildings, like quite common in Berlin or other cities. And we install our gateway here in the basement, usually in the heating room. And we go to the heating room because there is the heating device as well that we want to monitor. So it's best to actually have our gateway placed in there so we can get all the devices. And what we do is what you can see here in color are the sensors that we install. And those are installed by us, actually. That's why they have a different color. But we also read out existing infrastructure because most of the buildings already have, let's say, heat cost allocators or water meters installed. You might have them in your apartment, for example, right? And all those devices, they're continuously sending data. And what we do is actually through either access them directly or go through a repeater. So we read their data and also read the sensors that we install ourselves. So this is one side that we actually, where we have wireless connectivity. Then on the other side of our gateway, that's why we also have 2 antennas, right? We have our cellular provider where we are actually sending our data to the back end of Meetr. So in this way, we get our data connectivity. And here at this point, also a lot of people ask us all the time, why are you using cellular network? Why don't you use NB-IoT? And that's what we want to talk about today, right? So you get an idea about that. So one of the challenges that we're facing, because we're here down in this basement, is especially the next slide here, the signal loss factors of materials. So what you can see here, these are signal loss factors at roughly 900 megahertz. On the left-hand side, we get started with plaster timber, for example. You usually lose 2.8 decibels if you go through that material. If you go through a brick wall, you might lose 3.5, right? This is a standard brick wall, 89 millimeters. And then, so this left-hand side, these 2 constructions, that's what you find in older buildings, quite common in Berlin, actually. If they have been built around 1900, that's the common material. But then on the right-hand side, what you can see is the construction like roughly around 1950, where we start to construct things with concrete, reinforced concrete, and metal doors, right? Like these fire doors that we have. And what you can see here is also the loss factor is huge, right? Because of the metal inside the concrete, like the reinforcement, we lose 27 decibels on a concrete wall, and also on a metal door, we lose up to 35 decibels. So it's actually no way of getting a signal through there, right? So what we do just here at a glance, again, is like we have the devices on the left-hand side. We're using wireless M-Bus because most of the devices, as I already said, are already installed. So we actually need to read out those devices, and we can't place new ones because that would be a huge effort. So that's why we're using wireless M-Bus. We also support wired M-Bus. And the things we're investigating are MyOT, we're going to talk about that today, and also LoRa. But these are highlighted ones, the ones we're using currently. Then we collect that data in our mGate, and then we send it to our provider. And there we use GSM or LTE, basically, where we work together with Omnify. Then we have NB-IoT, actually, something we looked at, and also LoRa in this case, because you could use LoRaWAN to actually forward the data also to the internet. So what are the solutions we came up with, or what we did to try out? So this is the overview of the protocol solutions that we looked into, and so you get a better understanding how they work and how you can actually use them. So the first thing that we use, why do we use cellular network to send our data? Well, first of all, comparison to NB-IoT, we just experienced we had a much better coverage, especially EU-wide. So you usually know that you have a cellular network around, right? I mean, Germany is maybe not the best country for that, but let's say the rest of the European Union is very well covered. And it's a very reliable system. You use it every day. You can get network agnostic providers like Emnify, where you can select Telecom or, Telefonica or whoever you want, right? Which is actually quite convenient, especially on a day like today where Telecom has some issues. So it's quite useful. And this is basically what we're doing. And what we realized for our device is that it's basically usable for us from UMTS on. Why is that? Because actually sending data with 2G is not a problem. We can do that. But actually, if you want to update your IoT device with a few megabytes, let's say 100 megabytes or something, we discovered that usually the connections are much, much better if we have UMTS, at least like a 3G network connection. So we assume that our connection is stable from 3G to 4G on. So you have an idea about that. So on the right-hand side, you can see the comparison on how many kilobits you get through that network. And of course, in comparison to all the others, we're going to see, of course, the cellular network is just like way above all the others because we just have a much better throughput. But on the other hand, of course, we need a lot of energy, and it's a different kind of network, right? So another thing we're using is the wireless M-Bus 868 megahertz. As I said, most of the buildings have that already installed. It's mostly unidirectional. The devices are constantly sending information. That's what we're interested in. So there are many devices on the market. If you look for wireless M-Bus devices, you find a lot, and there are a lot of repeaters available as well. So that's quite interesting. You have a limited reach. It's not like LoRa or cellular network, right? And it is for buildings, for the housing industry, it's the de facto standard because that's what's out there. You have a data rate there of 50 kilobits per second, which is interesting. You have a reach in experience from our side, indoor for, depending on the building structure, but even in a reinforced concrete building, you can go to 4 to 5 building stories, which is pretty good. And you have a telegram size of 255 bytes. Now, if we compare that to LoRa, because that's something we're also looking at, like what if we would use LoRa indoors, first of all, right? Now, if we don't look at the coverage that we have outdoors, where the question is always, can I connect to LoRaWAN? Well, the coverage isn't as good as you might think. So that's why LoRaWAN is just not covering enough. But for indoor connectivity, it could be interesting. So you have an improved connectivity by modulation through going through concrete, which is quite interesting. But then on the other hand, you have the LoRa duty cycle. And the duty cycle, just for you guys, if you're not familiar with duty cycles, on the right-hand side, I made a little drawing for that. So basically, it's the idea, if you can see that you have an amplitude where you have your signal and you send that over time. And from your first amplitude to the second one, this is basically the period that you're sending. Now, the duty cycle limitation means you can only use 1%. In this case, for LoRa, it's 1%. You can only use 1% of your pulse width for that period of time. So if you want to send something for 100 milliseconds, you have to have at least like 100% of that on a time where you don't send anything, right? So, or if it's 1 millisecond, it would be 99, just like off and not sending anything. So you have this limitation that you have to stick with a 1% duty cycle, which is quite tricky because if you have devices if you want to send a lot frequently, this is limiting quite a lot. And then also you have few devices available on the market. It's not too much, so it's not, well, it's picking up and it's probably going to be more interesting in the future, but currently there are not too many devices. Then you have a data rate there, 250 bits per second to 11 kilobits per second. That's interesting, it's good. You have a claimed reach of multiple kilometers. I mean, also I must say this is a claimed reach, right? It's not what we experienced. We don't have proper data here that we can compare it with wireless M-Bus because there we have way more devices, so we have much better data. And telegram size also 255 bytes, so it's pretty similar. Then the other day, well, some time ago, actually, we discovered MyOT. I don't know if you ever heard of that. MyOT is a quite interesting protocol, also 868 megahertz. The interesting part is actually that it doesn't have a duty cycle. So it actually avoids that by splitting the telegram. This is what you can see on the right-hand side. You see a diagram where we have the frequency, and this is a common, let's say, protocol where you have a data package that is quite large, and you have an interference that is, well, interfering with your data, and actually you're going to lose the whole package because you might have a problem there. But then what MyOT does is what you can see at the bottom. There you have the frequency over time, and you see that it split up the telegram into different frequencies there. So if you have an interference in there and you lose some of the packages there, it's not a big deal because you have all these little split packages and they can be resent. So this makes it actually much more fault tolerant, and which is very interesting, and it also avoids the duty cycle. So this way you can send way more messages. However, one of the issues is it's quite high on resource consumption. If you want to use it, you need quite a powerful CPU, at least for normal IoT devices. They're not equipped with that. And there are few devices available. Also, the other day, we actually saw like a MyOT device card that you could buy, and it's PCI Express. And it's like, well, of course, we don't have PCI Express on our gateways, right? Because they're tiny and they're like custom made on our boards. So this doesn't really work for us. One of the things also, data rate is 407 bit per second, which is quite low. We have a reach claimed for 5 to 15 kilometers, and we have a telegram size pretty similar to the others, 250 bytes in this case. So we actually decided to stick, first of all, with wireless MBUS because that's what we are using on our end and also what our customers are using. So that's quite interesting, but we're still having an eye on LoRa and MyOT for the indoor connection. Maybe in the future, we can actually make use of that. So this was quite interesting for us to go through those protocols and understand how they work and actually try them out in the field. And then we tried other things to actually overcome our connectivity issues because we still had this problem of the decibels that we lost in the material, right? So what we tried was basically looking into different antennas and cables, what we could do there, right? So quickly for you, if you haven't worked with that, just a quick explanation about decibels and how that works. So what you can see on the left-hand side is we usually calculate basically, let's say, an effective throughput where we take the output power of the transmitter, which is decibels in milliwatt. This is usually expressed by dBm. Then we have a cable loss because you have your device and you have a cable to the antenna, even though maybe the cable is very short. This is measured in decibels, and then you have an antenna gain where you can actually gain some power, and this is measured in dBi, which is measured against an isotropic antenna. So what you can see on the right-hand side is basically, imagine if your antenna would be a perfect sphere, right? With 0 dB, that's basically the reference that you're measuring against. And of course, because your antenna is always slightly directed, you get some gain because you bundle, let's say you focus a bit in a certain area. Most of them don't have, let's say, a signal on top. It's not a perfect sphere, right? It's more like a, is that donut is a good description? I'm not sure, but you know what I mean, that at the top, there's no real reception. But what I also can always recommend, if you have a building where you need to focus on something, it's always good to get a real directed antenna. So this gives you a rough idea what we're talking about here in the following slides. So if you want to calculate that, here's an example of what we usually calculate. So you have a machine or a device, your IoT device with transmitting power, TX on the left-hand side, where we start with 20 decibels, for example, in our case. This is our transmission power. Then you actually calculate a certain cable loss, depending on how long your cable is, of course, and you get an antenna gain that actually gains some power again. And then you have basically the free space where you're sending data across the air basically to the receiver on the other side. And on the other side, you have the receiving part where you have an antenna gain again, where you actually improve your signal. But then on the other hand, you lose it again through a cable and you have your receiving power also on your device, or it's just 0, right? But what you usually experience is this is where also the numbers are coming from. If you're not familiar with it, if you see like a reception or RSSI quality of -80 or -70 or something, that's usually because from 20, we actually at some point go through 0 and then we go below 0 and we end up at -70 or something that the receiver can still recognize and work with. And so for the cables, here you see a chart how to actually select a good cable, for example. You have to be aware of which frequency you're using. So in our case, you can see the line in the middle roughly where we have 900 megahertz-ish, something like that. And what you can see here are different cables and how they behave, what their loss is actually in decibels per 100 meters. That's the scale on the left-hand side. And you can see all those curves of those cables that you can usually find in shops, right? RG58 and stuff like that. Here you can see what makes sense and which are the cables that are actually, well, quite optimal for your situation. This is also, I mean, if you're talking, you place a cable of 20 centimeters, maybe this is not really relevant, right? But if you're placing some meters, this is becoming quite relevant. And of course, it's also a price question. I mean, the better cables are usually more expensive. Yeah, this is just a rough overview, so you have an idea how you can actually, what you should take into account. Yeah, and Yannick,
yes,
we also, because you guys probably fell asleep already.
we thought we should remind all people here that we are also hiring. So as you heard, we have a lot of work to do, and I think it's a really interesting team and also a really interesting topic. So right now, for example, we are looking for front end and back end developers and also for senior product managers. So if you're interested, just get in touch and we grab a coffee together. And hopefully everyone is still awake.
So the next thing we looked at are actually evolutionary antennas. So maybe you followed this topic a bit, but some time ago there was like this NASA project where people try to use evolutionary algorithms to optimize antenna shapes, right? Which is actually quite interesting. So you can do that quite well. And NASA, if you read the reports from NASA, you will find this antenna here. You might have seen that in the news at some point. With this weird shape that looks a bit strange, right? Like a little kraken or something. So what NASA claims for the ST5310, which is this device here, they achieve a high gain of 2 to 4 decibels, which is actually quite good. I mean, it's 4 especially is quite impressive for an antenna. So you get that gain just through the shape, which is interesting. But of course, we have to take into account they're communicating in the vacuum and right, they have this ideal situation. And if you think about a gain of 2 to 4 decibels, I mean, we were talking about walls where we lose 27, right? So this is maybe not our bottleneck. So this was something we looked at, but then we realized like, okay, that's not necessarily the thing we should focus on because it's not the big deal, right? So what we looked at was like, first of all, we tried to use indoor antennas to get our connections straight. And one of the things we learned there, of course, is like keep your cable length short. I mean, it's quite obvious because for every meter or centimeter you lose, right? Do not crimp the connections yourself, just because if you do that, you will never be as precise as a fabricator who's doing that professionally. So just avoid that. And then we tried some antennas where we work with. We tried various ones. We ended up with D-Log 88571 for our GSM antenna, where we have roughly a gain of 2 dBi, which is pretty good actually. And for our 868 megahertz antenna, we're using RF Solutions. There we have an antenna, you can see it there. And we have a pretty good gain there of 3 dBi, which we're very happy with actually. So you see that if you try out other antennas, you will actually see a huge difference there. So it's quite good. What we learned in that process also is like if we are having some kind of responsiveness to our hardware, we should usually add that if people are installing that, especially if people are installing it who are not part of our company directly, but people, let's say an installation partner who we are hiring, who's going to install the hardware that you can see here in the background in the basement. It's good to have some sort of responsiveness about the cellular connection. So what we did was basically displaying the connection quality on a UI, so you can actually use that with a mobile phone and you can see, right here, there's like good LTE reception, so maybe this is a good spot, or if I move it a bit to the left, it's getting better or worse. So I think it's always something you should keep in mind to ease your installation process and show at what reception level your device is. So this is quite helpful. So what we did in the end, well, first of all, we had our M gate with the 2 antennas, and what you can see here, we have 20 dBm. We get another 2B from our antenna. We have a very short cable, so I just dropped it here in the calculation. And then we have the minus 27 decibels from the concrete wall. So in the end, we have minus 5 dB when we are reaching the outside of the building. And you can imagine with this minus 5 decibels, we don't go anywhere, right? It's like no reception at all. It's quite poor. So, well, actually, what we then came up with was the easy solution of thinking, okay, right, let's take our device with 20 dBm, put a cable in between, drill some holes if possible, or go through windows, right? And then we lose maybe 2.5 decibels, depending also on the length of the cable, but that's what we usually use, something like 2.5 or 4 is something we lose. And then outside we have another antenna where we have plus 2 dB or 3 in a good case. So we end up with 19.5 outside of the building. So that's pretty good. And from there on, we can actually work with, we will always have a good reception, right? So for that, we recommend from our learning was like, okay, first of all, if you want to go through a window, because you probably don't want to drill a hole, and in most cases you can't because there's like fire protection rules and stuff like that. So there are flat window cables that you can actually put through windows in basement, which is quite good. Then one of the things you should think about is always vandalism or theft, right? That could happen to your antenna if you want to place it outside. And also exposure to rain, sun, wind, snow, like that's also a critical part. That's why it's good to use proper outdoor antennas. We, for example, use D-Log 88749 and D-Log 89533 for 868 megahertz. Both of them have roughly 2 dB gain. And what we recommend is actually to look for a good dripping edge. So keep in mind, if you have something like this on the right-hand side where you have this little edge here that you can screw to the wall, the problem is actually, yeah, usually if it rains, the water gets easily stuck there, and then you have at some point water in this antenna housing, which isn't too good. So what you should think about is like how to install it in a way, like let's say in a bit inclined way or tilted, so it doesn't really, like the water doesn't get stuck there and can actually drip off. So that's something you should really think about if you install an antenna outside. Most of the antennas that you can buy don't really provide that as a standard. So, and yeah, this is it from the antenna part. And then we also briefly want to talk about bandwidth optimization and how important that is for your IoT project, because we also realized that this is not always optimized. And yeah, this is some learning from us, what we did, like also optimize your bandwidth, because it's quite important, right? Most people don't think it's that critical financially, but if you, for example, look at costs that you have, let's say 500 megabytes for example, €2 per month. This is actually a price we would wish for. Maybe we could get that from Amplify one day. These are not the real prices.
We have to talk about that, Max.
Yeah, we discussed that after. This is our dream price or something like that. Yeah, but if you have a price of €2 per month, for example, and you scale that down to 250 megabytes, where you might pay 1.20 euros per month, you're going to save 80 cents per device, which doesn't sound so much. But of course, if you have 10,000 devices, we're talking 8,000 euros a month, right? So this scales up quite a lot. So what we always recommend is like actually use the dashboard a lot on Amplify. Also check, I mean, they have a good API and they also have a dashboard where you can check that. You can check the quality and then how much you're sending on data, how much you received, and upstream, downstream. That's pretty good. So you get an idea of like how many megabytes are you actually using, and accordingly, you should of course optimize that. One of the things we would recommend to you is always like split your data in two kind of types. One of the things that you will always have in IoT are health messages. So health messages are the reporting about the status of your device. So they should be frequent as possible. Little data, it's not much that you're sending. You don't have a high security relevance usually, because most of that data is not really critical. If someone really gets it into their hands, right, you won't send any secrets across that message, right? It's just like, okay, maybe my battery status or something like that. So what the good thing is there, you usually can go with a fixed schema. So you don't have much variable data because you know what you're sending, because usually you're designing that yourself. So that's easy. So be slim, be verbose, like tell a lot about the status of the device, use fire and forget, and maybe use MQTT, for example, to connect to the backend and send out your messages, but always keep them small and tiny, because actually that adds up to a lot of data in the end. And then you have your data messages where you have your packages that are really important to you, because these are containing the data that you gather from devices or anything else. So what we do, because we have the data, send it out scheduled, right? Don't send it out all the time. You have a lot more data. It's high on security standards. So yeah, use SSL encryption. Make sure you're maybe sending encrypted packages, because also, yeah, mostly it's containing crucial data. And then also another thing is that data might be variable. So you don't really have a fixed schema you can go with. On the next slide, we can quickly show that how to optimize that. But that's important to keep that in mind, that these two types of messages are very different. On the data message, we would always say, well, send data only if needed and drop rubbish data. Make sure if you collected a lot of rubbish data on your device, make sure you don't send that to your backend, because you don't really need it, right? So have some sort of filtering. And another thing is like use gzip compression, for example, or any other type of compression, but make sure you're not sending everything without compression from the device to the backend. Just an example here, for example, if you have an object, as you can see here, an example, message test1 with an integer of 32 bits in there. If you would express that in JSON, right, you could go to 7 bytes. And I mean, this is pretty popular right now to use JSON for everything as payloads, also if you just do HTTP posts. But then you could optimize that if you're using protobuf, for example, with 32-bit integers, you end up at 3 bytes, which is much better for this payload here. But then actually, if you can make sure that this is not a 32-bit int, but it could be an 8-bit int as well, so from 0 to 255, actually you could use byte packing as well, and this goes down to 1 byte, which actually is quite a huge difference from 7 bytes in JSON to 1 byte in byte packing. So this is something you should always keep in mind when you're designing your protocols or your standards and how to send data to the backend. Make sure you're not wasting too much here. Yeah, and that's actually it from our learnings and how we tackled the issues by in the end installing antennas outside, which were helping us a lot, especially for the cellular connection. And now I would like to open up the questions, the Q&A. We have a question panel. If you haven't used the webinar tool here before, on the right-hand side in your menu, you should see a chat menu, a chat bar that you can unfold, but we don't want you to post their questions, but there's another tab called questions. In there, please add your questions so we can actually go through them and answer them.
Yeah,
so thank you very much.
Thanks for reminding. I forgot that in the beginning. Yeah, so please use the question panel. And Max, Yannick, really great presentation, very good insights. I think key learnings for people that are interested in the solution and want to develop such a solution. I have a couple of questions because I was unsure. Like you said, you offer your service like as a service, right? Your monitoring solution. How does it work? What's your pricing model, and is connectivity included in your offer?
Yeah, thank you, Christian. Yeah, really good question. So we are offering different service like packages that's really dependent on, for example, what support you need or how many data points you wanted to collect. Also on how many flats a building has. We are charging this software service fee monthly, and depending on the connectivity you choose, like this is included in our software as a service fee. So the price is including the connectivity. From time to time, we can also connect via Ethernet as well if this is needed. But we learned, and that I think also Max mentioned it, that your connectivity via GSM or LTE is way more reliable than the usual router, for example, you have. Hope this answers the question.
Yeah, thanks, Yannick. Yeah, I see that now that gave our attendees a little bit of time to type their own questions. Here, there's one. What are the communication protocols that you have had to integrate within existing buildings? And maybe I also read, you talked about this retrofit solution, and so I believe you always have sensors already deployed, and you also have applications available. What's your approach to integrate them?
So mostly we have sensors with wireless M-Bus deployed. You find a lot of protocols in most of the buildings. First of all, you find a standard on connecting to them, like an interface that they have, but then also all of them mostly have their own protocols. So you can connect through RS485, for example, or through M-Bus as well. It's actually, there's a lot of bus systems out there. We don't cover all of them currently, but our M-Gate is designed, the gateway is designed in a way that we can actually support those. So we have like a modular system where you can plug in some devices that actually help you to connect to other networks. So, and depending on what we find in a basement, we connect to other devices, but it's also depending on the use case and also what we're working on with the customer. But you find quite a huge diversity on protocols down there in the basements already.
Okay. And from the application integration, so do you integrate an existing, if there are solutions deployed, do you utilize the APIs of those solutions?
Yes, we also connect to APIs. So that's also one of the things we do. For example, if there are other solutions out there, there's some elevator companies that offer APIs that you can connect to. So if the customer has like has this account where they have ability to connect or use the API of, for example, Kone has that, so we can actually connect to that API as well.
Okay, thanks. And then there's a question about M-Bus and M-Bus wireless. If it's mainly used in the EU, or also if it's popular in the US, do you have any view on this? I know that you are mostly in EMEA.
Yeah. So we're mostly focusing on the EU market and also on Germany. It is quite common in Germany. I'm not sure how common it is in the States, for example. Not really sure. Yeah.
Okay, thanks. Do you have any experience with Sigfox?
We didn't try Sigfox. Yeah, that's a good one. We didn't use Sigfox, but for some reasons, because we don't want to, first of all, we don't want to go through a provider that offers the network. There's some issues with that. One of them is, of course, you're handing over the data to a third party. Another thing is, of course, the pricing model. I mean, this would work if that price is fine. That makes sense, of course, but also there's always the question of, what if I go through third-party networks? So if you're aware of the security of your data, this is getting very challenging. If you deploy a product, for example, of a customer with sensitive data, you can't just use a third-party provider, because you have then some liability issues, because usually you have to make sure that it's only going through your servers, or at least like through a controlled system that you actually know what's happening to the data. In that case, you always have that issue that you have this other third party in the data transmission as well.
Okay. There are no other questions. There's one question. There's one. Is there any work in the industry to create a common protocol?
Yeah, that's a very nice question. Yes, well, in the end, the open metering system, what we talked about, wireless M-Bus, is that kind of open protocol, right? So it's called open metering system. All the protocols are public there. It's not a problem to implement your own wireless M-Bus devices. So this is kind of the approach there. And that's why we're also supporting that, and we're using that a lot, because we think that's the right way to go. we're not too happy with proprietary protocols because usually they're not, well, it's tricky to actually implement them and then also to find devices for that. Well, OMS, the idea is actually that there are a lot of devices out there and all of them speak the same language.
Also, maybe here to add on this question is there are a couple of platforms and partner platforms where companies start to build or think of creating a common data model, but those are really mostly on the very beginning. Obviously, this will be interesting in the future as more services get digital. And yeah, this will be also really interesting where the journey goes there, right?
Yeah, definitely. Yeah.
I see another question. Is there a similar effort to monetize microtransactions? Okay,
that's an interesting question. Not sure what your question is in regards to this. Maybe you can specify that a bit more.
VJ, do you? Oh, maybe you take that offline, VJ. Yeah, that question is from you, and reach out directly. Okay,
sure, of course.
I think
afterwards, if you really have something pops up in your mind, feel free to get in touch with us, and we can also discuss afterwards. Sure.
Yeah, I think that concludes the session. I don't see any more questions. I would we will share the presentation and the recording, of course, so you can have it on demand. We can again and share it with colleagues. I hope you find this useful. Please also let us know what are the topics you want to see us presenting in future webinars, and just provide feedback. Happy to connect with you over social media. Okay, thank you very much. And
thank you very much.
Thanks, Mark, Yannick. It was really a pleasure. A really good presentation. For myself, I took key findings with me, and I'm happy that we got you on board.
Great, thank you. It was a pleasure to be guest here.
Thank you. Have a great day.
You as well. Bye-bye.